Assalamu alaikum wa rahmatullah. I welcome you all to the fifth video. In this video, we will see how problems are solved using collisions, conservation of momentum, conservation of energy, or otherwise. The first problem here says, this is example 6.10, two bodies A and B of masses 4 kilogram and 2 kilogram, meaning body A has a mass of 4 kilogram, body B has a mass of 2 kilogram. They move towards each other with velocities 3 meters per second and 2 meters per second and collide, meaning A has a velocity 3 meters per second, B has a velocity 2 meters per second, and they collide with each other. If the collision is perfectly inelastic, you see, remember, perfectly inelastic is when the two bodies stack together and they move with common velocity after collision. Find the velocity of the two bodies after collision, meaning after they collide, what is the magnitude, what is the size of their velocity together. Find the total kinetic energy of the system before and after collisions. Remember this formula. This, you are going to use this to get the total kinetic energy before collision, and then you use this to get the total kinetic energy after collision. Not only that, they also say that hence calculate the loss in kinetic energy. Remember that total kinetic energy before collision is greater than the total kinetic energy after collision, so the loss will be initial total minus final total. So as we can see, here is the first body with a mass of 4 kilogram, and this is the velocity, and it moves to the right. And I have the second body with which is of less mass, 2 kilogram, and it moves with a velocity 2 meters per second to the left. Now, before we move on, you have to remember that since velocities are vectors, if they have opposite directions, one should be considered positive, the other one should be considered negative, regardless of whether it is written as positive or negative in the problem. In the problem, all the values are given as positive. But remember, because they move opposite to each other, they say they move towards each other, so you have to take one positive, the other one negative. Here we are taking this as positive because it is in the direction of positive x, and this one is taken as negative because it is in the direction of negative x. Now, after the collision, they stack together, so you have to add their masses 4 plus 2. The 4 you have here, the 2 you have here, this will be the total mass, and then since they are together, the velocity is common velocity. This should be our u1, this is our u2, this is our m1, this is our m2. Now, we are going to apply the momentum conservation principle. Total momentum before collision equals total momentum after collision. Momentum of this is mass times velocity, 4 times 3 plus 2 times 2. But remember, this 2 is negative. That is why it changed the plus sign here to negative sign. So the 2 you have here times the 2 you have here is equal to the total mass of the system times their common velocity, 4 plus 2 times the common velocity v. This is why in bracket they wrote this as a guide. Momentum before equals momentum after. So here 4 times 2 will give you 12, 2 times 2 will give you 4, so 12 minus 4 will give you 8 equals 4 plus 2, 6, 6 times v will be 6v. Okay, you divide both sides by 6 and your v will be 8 divided by 6, 8 divided by 6, 1.333 in meters per second. So they will move with this velocity. Okay, why did we say that they move in this direction? The reason is simple. If you look at the bodies, m1 is greater than m2. Also, m1 moves with a velocity greater than the velocity of m2. So it's clear from here that if they collide, they will move in this direction, in the direction of m1. Okay, now the next problem, this is their common velocity. Remember, you are asked to find three things: common velocity, total KE before collision, total KE after collision, and loss in KE. So KE before collision is given as, remember, half m1 u1 square. Half, then m1 is 4 mass of the first body, u1 is 3, so you have half m1 u1 squared plus half m2 is 2, u2 is 2, and you have a square. Now someone may say, why is it that my 2 here is not negative? I use negative here and it is not negative. Of course it is negative. When you square negative 2, open bracket, but this is how, try this with your calculator, open bracket, minus 2, close bracket, squaring, and it will be positive again. This is why the positive sign is ignored here. Not because it is completely ignored, but because the square here cancelled the negative sign. So you have half 2 by 2 squared. When you if you are using a calculator, you simply take your calculator and you press 0.5 for this half 0.5 times 4 times 3 squared plus another 0.5 times 2 times 2 squared, and then you press equality sign. You will get the 22 joules straight away. You don't have to waste time splitting the calculation into steps. This will waste your time, as your exam and CA questions will all be objective. You have to know the shortcuts of getting answers without prolonging, without wasting time. Kinetic energy after collision is here. Now remember what we said here. To get the kinetic energy, if the system stuck with each other after collision, you simply use this one: half, open bracket, mass of the first object plus mass of the second object, close bracket, the common velocity square. That is what they use here. Now in this book they did not write the formula here in the process, but my advice is that always write the formula before you calculate. Okay, always write the formula before you calculate, because this will help you avoid mistakes. Okay, so half, mass of the first object is 4 plus mass of the second object is 2, close bracket, the square of the common velocity. You calculated the common velocity here, you got 1.333, so you put it here, you square it. Again, use your calculator directly. Just take it and press 0.5, open bracket, 4 plus 3, close bracket, times 1.333 squared, and press equality sign. You will get the 5.33 joule straight away without wasting time. Again, if you want to get the loss in kinetic energy, you say kinetic energy before collision 22 joules minus kinetic energy after collision 5 joules. You see, initially you have 22 joules. After the collision, it dropped to 5.33. It means you lost 16.67 joules. This energy is converted to sound energy, and some of it heat energy, and possibly light energy. Sound, heat, and light energy, these are three possible energies that are formed after collision.